Every now and then you can strike quite lucky on eBay, and just a bit of surfing will actually come across, some quite good bargains. Test equipment very rarely comes up as a bargain on eBay, but every now and then you're lucky. And this was one of these situations where I was searching for test equipment that was faulty, really more to make videos than anything. I was looking for possibly sort of like a small multimeter or something like that. But I came across this listing here. Obviously the seller didn't really know much about this meter. They didn't know if it worked or not. They were selling 4 other items, and they were all listed as powers up but shows inaccurate readings. So I had a look at the seller's other items, and they were selling things like clothes and things. So I felt that was like a cop-out thing. Basically, they didn't know what they were selling, and it was probably worth taking a bit of a chance on buying it. This is a HP or Hewlett Packard 3457A multimeter from the 80s, mid 80s. Very high, 5.5 digit meter, 5.5 count digit meter, high accuracy, and got a good reputation for being a sort of like a long-term, reliable, stable multimeter. It was in pretty filthy condition when I got it, and I've given it a bit of a clean up, and you can see it's in actually quite nice condition now. There's no sort of nasty scratches on it or anything. If I can get the camera to focus, you can see it's in pretty nice nick. The keys are all sort of like no chips in them or anything like that. But so I thought, well, it was up initially, funny enough, for eBay are doing a different thing now, where you actually, I think it was £50 or best offer, £50 starting bid or best offer. And I thought, well, I wouldn't mind it, so I put in quite a reasonable bid, but it wasn't, or a reasonable offer, but it wasn't sort of like £300-400. It was a sort of like a lower value than that. I don't want to exactly say what it was, but and they, after a day, I was thinking, I probably won't get probably won't win it, and then they accepted my offer. So sure enough, it turned up in the post this morning. I was a bit disappointed by the way it was packed, and I did notice that on one of their other feedbacks that the packaging was. They charged me quite a lot for packaging, and they used My Hermes, which is one of the notorious couriers for sort of dropping and kicking stuff about, and they've got sort of quite a bad reputation. And this was packed in a single layer of bubble wrap in a cardboard box, so it was just rattling around in the cardboard box. And they charged me £15 for postage, so I'm not too happy with that. So that'll be mentioned in the feedback. But anyway, it arrived, and it arrived in undamaged condition. So obviously the particular courier or the particular driver of the van was a bit more respectful with stuff. So that was good. So I got it to work, and it was unboxing it. Yeah, and it looked okay. So I powered it up, and it all came up. All the display came up, and it all looked fine. So as I was at work, I connected up to some known accurate readings, known references, and it was certainly very, very close. I mean, it was. I was comparing it with the 34410A HP, which we use a lot of, and it was within a few millivolts or so. And I thought, well, that's great. It seems to work fine. And I ran an auto calibration on it, and let that run, and it passed that, and it said it was no problem. But when I ran the test function on it, it fails with it says hardware fault, and it's error 0. Now, reading through the instruction manual, that suggests there is a sort of higher level hardware problem. But ignoring that, I carried on, and I thought, well, I'll check all the other ranges to see how it works. Ohms range seems accurate. The only thing I could possibly see is that the ohms range doesn't always auto range correctly. So I'm not entirely sure if that is the problem. There are a number of calibrations you can run on this, and there is an adjustment inside for a trim pot that I'm not entirely sure. I need to go through the calibration process, but I haven't even touched that at that point. DC volts worked correctly, AC volts was working correctly. Currents, I checked both the currents, they work correctly. I haven't checked frequency and things like that. But it was just that error message. Apart from that error message, everything seemed to be working reasonably well. So I left it on at work, and I just carried on working. I just left this on. Just I thought, well, I'll waterproof to see if it was going to sort of blow up an X cap or something like that, or a Y cap or whatever they are. And I was sitting there working away, and this was in the background, and I was suddenly aware of this sort of crackling noise, and I thought, what the hell's that? And straight away you sort of think, bloody X cap's failing, so I whipped the plug off the back, and sure enough, there was that lovely smell of burning X cap. I don't know if anyone's ever had one fail, but it's actually not an unpleasant smell. I don't find it an unpleasant smell anyway, but it stunk the workshop out. And my boss came in and said, what's the smell of burning in here? And I said, I had my meter plugged in over lunchtime, and the cap blew up. He said, oh, okay. So I don't think I think he probably knew I had it. I was messing about with it in work time, but he didn't seem that bothered, to be honest with you. So unfortunately, I can't demonstrate it this evening because the input filter has actually failed on this, and it's a notorious problem with these input filters. And there is a known problem with the Solitron meter I've got, and it's these filters here. It's an inbuilt filter into one of these Iec sockets, and they've got the capacitors are mounted inside. And the only good thing about them when they're mounted inside is that they sort of do contain the sort of explosion and all the pus that flies out all over the place. Now I was hoping to replace it with this type of IEC connector, but unfortunately that's not going to happen because this IEC connector has a built-in fuse, and that makes the this depth a lot deeper, and it won't actually fit into this multimeter. So let me just turn around to show you what type of fitting it's got. Here's the back of the multimeter, and here's the Iec socket, as you see just here. Now it's the narrow type. Even though it is filtered, the fuse is external on this one, and also you notice it's been riveted in, so I'm going to have to drill these rivets out to get this filter out. I was hoping I could demonstrate it this evening. I actually checked across the live and neutral with the connection internally disconnected, and it's showing sort of like a couple of K. And when I checked this one across the same thing, it's like a meg, because there is a capacitor in series, and that capacitor's gone short. It's just putting power, AC current, straight across the series resistor that's supposed to be there to protect it. So let's open the top up and have a look inside. And there's not, at the moment, not much to see because I've got all the screens on. Let's see. This is the filter section here. Zoom in a bit so you can see. Now you can see the filter here, and this is the filter, but that I need to replace. That will have to be removed. I've got to drill the rivets out. So the first thing will be is to drill the rivets out, get the filter replaced, get this thing packed up. Have a bit of closer look at the error message, and also this has a backup 3-volt battery inside it. I actually checked the battery and it was about 3.4 volts, which to me seems a bit high, it's a bit odd, and it's a Panasonic battery, so I think the battery's been changed at some point. And this error message could be it's lost some of its volatile memory. Anyway, so let's proceed with getting this back changed. The battery's about to run out on the camera, so I've got to be pretty quick and see if we can get this thing powered up again. Let's see if we can get this filter out because it's been riveted in. I'm going to have to get the drill on it and drill the rivets out, which I don't know why they couldn't use screws, but I suppose they had their reasons. I wonder if it's because they think that the rivets give a better earth connection or something. So let's get a drill on it and see if we can drill this out. We just want to drill the rivet caps off. The bluntest drill I've ever come across. Let's try another drill. These are steel rivets. So it is cutting in. It doesn't seem to be cutting very well. Not very easy to see. Not much fun watching me drill rivets out, I suppose, but it's all part of the repair video. Where are you? Where am I? Okay. Okay, let's find a drill that actually cuts in and see if we can carry from there. Okay, to spare you the pain of watching me drill this thing out, there's the filter. Now what I'm going to do, I think for the meantime, is going to just see if I can disconnect the, get it apart and see if I can actually dig out the filter. It's going to be stinky inside, and then see if I can wire it up. It's a Schroeder filter that's common for these to fail. Looks like there's a vent plug there that's sort of blown sputum everywhere, and let's see if we can get this thing apart and fix it. Okay, I've powered the unit up so you can see what's going on. I've just tapped in a sort of temporary mains filter so I can actually use it. I've got one on order. You can see this seems to be working perfectly well. We've got a bit of a DC offset by the looks of it on the output, which is what you come to expect with a very high impedance front end. Now, there's quite a long-winded calibration process or error checking sequence to find out what's actually wrong with this thing. I'm just going to run through that now. Basically, there's a self-check function on here, and if I press this blue button and then test, it will perform a self-test and it will come up with an error. And this is the initial problem that I'm finding that we need to try and resolve. And you'll see here that it's come up with test failed. Now the procedure for that is, it says here, run an instrument self-test, press the blue shift key and the test key, which is what I've just done. Display will show testing, and while it takes about 7 seconds to complete, it says, if the display shows test failed, check the error message by pressing the shift key and the error key. So that's shift key, and that's the error key on the right hand side, just out of frame. I'm trying to get it all in frame, but it's a bit difficult to get it all in frame together, but there we go. And it says hardware error. Okay, and it says if the hardware error, if the message reads hardware error, check the auxiliary error. Auxiliary error messages for additional information. Press the blue key and number of power line cycles switch. We've got ACAL, and we scroll down to auxiliary error. Auxiliary error, and we press enter. And our auxiliary error, as you see there, is auxiliary error 256. And according to this, auxiliary error 256 is AC attenuated frequency compensation is beyond tolerance. Press the AC, perform an AC converter frequency response adjustment, paragraph 5-7 in the manual, and repeat steps D through H of this process. So the manuals, as always with Hewlett-Packard stuff, are very clear. And I think that will probably be the next thing to check. So I'm going to go through, find this part of the manual and see if we can run through this now. Okay, let me read you what it says in 5.17. It says, this adjustment is not required unless the self-test response is hardware error and the aux error is 256. Adjust the AC converter frequency response as follows. Remove all power from the 3457A line cord and external inputs. Loosen the two screws attaching the rear terminal assembly and remove the assembly block. So that's the connection on the back. Turn the instrument upside down and loosen the 6 captive screws in the bottom cover. That's what we've just done. It is not necessary to remove these screws from the bottom cover, so they're basically like captive screws, so they just fall out and they're held in by their threads. Remove the unit, return the unit to the upright position and remove the top cover. Okay, we've done that. The front panel of the instrument faces you. Move the plug-in support assembly slightly. This is, where the instrument panel instrument facing you, move the plug-in support assembly slightly to the left and release the locking tabs and lift the support assembly. So let's get this back assembly thing out, so it's the back connection out, and get that sorted out. Okay, so what it's basically telling you to do is to lift this cover over and fold it over the front screen so you can get access to a trimming capacitor down here. It's not very easy for you to see with the camera. I'll find you a better position to see it. You can just about see it there actually. It's not vital that you see it, but that's the position it's in. It's that red highlighted area there. There's a trimming capacitor there, and that's the adjustment. This adjustment here is the one we're looking at. So you don't really need to see me adjusting that, but what I will do is actually, I just wanted to show you, as I say, where it was. I'm going to prop this up somehow so I can actually see the front panel. Put a screwdriver in here or something like that, just to pull the front panel up so I can see what I'm doing, like that. Let's repower the instrument. Okay. Now, let's just come back a bit so you can see what's going on. Because I want you to see the front panel, because I don't know if this is going to work, but this is a procedure to supposedly fix this problem. Let's bring it around a bit so you can see the display easier. Okay, let's read out what it says. It says, run the reconnect and turn the power on. Run the AC Auto Cal routine. Press Auto Cal configuration key. Enter the number 2. So Auto Cal number 2. What else does it say? I press enter. And then it says, what does it say there? Just try and get this, make sure I'm getting this right. So enter diagnostic routine number 8. Press the blue shift key and the auto 0 key. Auto 0 key. This is delay. What I'm going to do. Scroll down to show it says diagnostic. And there it is. And then press the enter key. Enter the number 8 and press enter key. 8. Enter. I don't know what that's doing. Failed. Okay. Now then, it says use an insulated adjustment tool. Adjust C332 gain flatness adjustment until the reading indicates past 0. Ooh, this is exciting. Okay, so it's reading high. That's interesting. Let's get our twiddler in here. Oh, I do like a bit of a twiddling and things like this. It's never quite the same with software control, but if you've got something you can actually twiddle inside, it's great. So let's get inside and so we can bring this down to 0. So I'm lining up the trimmer capacitor. Trimming tool wasn't fit. Oh, it's a bit of an anticlimax that was. Let's find a better tool. Here's one. Come on. Okay, we're in. Right, let's try and get this down to 0. Turning it. Not doing a lot, is it? Still says failed 4. Press anything else do I have to do? Use the insulated tool to adjust C3. Gain flatness adjustment until the reading reads 0. I think I'm doing everything right. Use the insulated tool. Let's go a bit further. Not doing a lot, is it? Not making any difference at all, this, I don't think. I'm adjusting the right bloody thing, aren't I? Yep. Okay, I'm not getting any adjustment at all on this, so there's obviously something wrong with the AC side of it. Whatever I do, it's not making any difference. Fully out. Nope, I can't adjust that out. So, does it say anything about what could be wrong? No. So that's not adjusting out, so there's obviously clearly something a bit more seriously wrong there. But that's how you're supposed to adjust it, so let's just quit out of that. Can't get it to quit now. Just turn it off and back on again. Okay, do a self-test again. Expecting a fail, yeah. So it's the same thing. So it's clearly something a bit, unless I'm doing something wrong, which I can't say I am, there's something a bit more serious than this and we need to look a bit further. Okay, this is the inside of it. It's sort of typical sort of build quality for Hewlett-Packard, a sort of work of art. Much modern, more modern than sort of like the spectrum analyzer or the signal generators I've got. You can see that these are all relays that are all suspect of failing, and this I think is the AC board here. This is the trimming capacitor just here that I was adjusting. That makes no difference at all. So I'm suspicious of something possibly on this board packed up. It could be one of those relays. Something as similar as that. Something's been zapped on the front end. Difficult to know. I don't know if you can see down here. It's been probably out of view. Got a spark gap for voltage over voltage protection. Lots of ferrite beads around windings and wires and things to keep down noise and keep down the sort of emissions as much as possible, to keep the noise level down as low as possible. Because this meter goes down to such a low input voltage, so like 100 picovolts and things like that. I think nanovolts. Sorry, is it nanovolts, picovolts? What's after microvolts? Nanovolts, isn't it? So it's down to sort of like very, very low signals. Electrical noise is a big problem, and so is thermal noise as well. Just the heating of any of this board will result in spurious readings on the front panel. So more than likely there's a problem on this board. I'm pretty sure this is the AC board. I need to sort of do a bit of research on the internet, see if I can find anyone who's got any ideas what could possibly be wrong with this. It's nice to see that actually most of these devices here are not HP numbers on here. We've got an LM339 here with a date code of, what's that? Date code of 95. So for my workshop this is pretty modern gear. So it looks like it's not going to be too hard to track down parts for this. The battery is actually in this metal case behind here. I have had this off, and as I say, it's got a Panasonic battery. That might actually be the original battery, actually. 1995. Okay, it's coming up 24 years old, but it's probably still fine. The consumption. It's a big battery actually. It's like a C cell, physical size, and it's pretty drawing a few hundred microamps, you know, just to keep the memory retention. So I don't think that's a problem. Certainly none of the firmware seems corrupted or anything. I think it's just this reason why for some reason we can't adjust this calibration. So I'm going to go, I think I'll go on to the EV blog forum, and hopefully I'll get some help there. Pretty confident we can get this up and running, and even if we don't get this AC side working, the rest of it's fine. The rest of it, the calibration is passing fine, and the meter works fine on DC. And very rarely use meters like this on AC for accurate reading, but it doesn't mean that I don't want it to work. I would like it to work perfectly. So let's see what we can see if we can get any headway on the EV blog forum, and we'll maybe get some pointers. Right, we've ascertained that there's clearly something wrong with the AC section of it. If I've got this unit on AC and I feed in, say, a 10 volt signal, I'm getting something like 10 millivolts through. Hence why it's failing its self-calibration. There's no signal getting through. If you look at the scope here, you'll see my sine wave signal here. We're feeding 5, 10, 15, 18 volts peak to peak into the signal. And that should come out on this red wire here. As you see, there it is. If I select DC volts, there you go, the waveform disappears. So the switching to the AC board is working. So that's our first thing confirmed. So that's basically has straight away narrowed it down to this AC board. This is the AC board circuit diagram, and that signal is coming through on this line here. It's coming to these, what it says they're ICs, but they look like relays, and they feed through to these pot down. There's a couple of pot down resistors here. They look like their pot down resistors are 302 and 303. Now I'm just going to see if I can find these on the board, and if I can find them, see if they've got any signal on them. I haven't actually got a layout for this board. I didn't print that out, but I'm just going to bring this a bit further forward so I can see what I'm doing. Unfortunately, this unit doesn't stand up on its own. It tends to try and fall over all the time. So there's 301 there. Just trying to see if I can find 302 and 303. There's a relay here, so that's probably the main switching relay. I'm just seeing if I can find that IC number. Maybe that will help. IC 302. IC 302. I've got CR 302. That's what it means. Oh, that's a typo, because that is actually a, yeah, that must be a typing error. Got IC 301 and IC 302. We've got K301 there and 302. So these are the two switching relays. So it's very common with HP stuff to get the typos wrong on this. So I'm just having a look now to try and work out if I can find any of these signals. 373 and 374. Oh, there's 374. These are 100. Are these 10 megs or 100 mega ohm resistors? Okay, we've got a couple of resistors here, and they're actually 100 meg. So it should have a signal. If it's on AC, I've got the signal. You can see the scope still. I've got a signal there. I should have a signal here. On the other end, maybe. Okay, there's on one end, and that's the 10 meg. So that looks. Just check see how those resistors are wired. Are they in series? Yes, they're in series. So the signal's getting. Looks like it's K301. No, it is K301. It's just because the print's so poor. It looks like IC. So it's K301 and 302. So the signal's getting through K301, which is that relay there. That looks correct. And then K302 should go to R302 or C302. They're more likely to be up here. No, this is C302. And I've got a signal there as well. The other side of C302 I haven't actually. So what does that suggest? No, that's alright, because that looks like it goes down to That's interesting. I think that's interesting. Is that interesting? Is that? I'll just show you. Right, we've got signal coming into the other 2-1. Let me see, I'll zoom in a bit so you can see a bit easier. Signal coming into this point here, so that suggests that relay switched correctly. I've got signal on C302 here, but nothing on the other end of C302. I'm not sure. Oh, there we go. It looks like that's a... Is that a ground point? It doesn't look like it is a ground point, actually. It looks like some sort of shield. I've got signal on one side of that capacitor and nothing on the other end, but there is a capacitor on the other end of it as well, which is electrolytic. So that's probably okay. So next thing I want to do, sorry, I'm out of frame. So repeat that. I've got signal coming on one side of that capacitor, and now I want to check to see if I've got signal coming in on the other end of that resistor. I think it depends on how this relay switched, but it looks like the signal's coming into the unit. The next thing will be to check is these JFETs, which are also quite commonly can fail short. JFETs can fail short, or they can actually fail open. So zoom out again so you've got the scope back in view. So I'm just going to probe around so I can see if anything sort of looks a bit amiss. So we've got signal coming into the top of that. Okay. See, it does say in the manual that this is this point here is the trimming capacitor, and it does say that's connected to the high terminal. And if that's connected to the high terminal, I'm not getting anything coming through. So I'm starting to wonder if, yeah, maybe K302 is not working correctly. So short of lifting that board out and getting to the other side of the connections, it doesn't look. Let's have a look at R305, which should be nearby. 305. Find R305. I need to get a layout for this really. There's C305. C305 any good? Yeah, C305 is in parallel with it, so let's just have a look at either side of that. Nothing. Nothing. Right, okay. Well, that sort of suggested something straight away. That trimming capacitor is needed to adjust the flatness response, and if I'm getting nothing coming through there, that would suggest that either that relay's gone duff, or there's a short across C305, or maybe this resistor here. So I suppose I could do a couple of static checks to make sure there's no short. I'm just going to turn the unit off. I'm going to use the Flint multimeter just to check across. I mean, it's unlikely, to be honest with you, but it will rule out that there is no short. So I'm going to measure across that capacitor there to make sure there's no short. And the meter's gone to sleep, like they always do when you turn away. C305. Just make sure there's nothing there. I've got 1 meg, so that sounds probably fine. There's 1 meg across there. That's probably sound like a matching resistor. Yeah, we've got a 991R resistor across there, so that looks fine. So we're not getting this signal to that point. Now, what I can try and do is change manual range changing just to see if that gets the signal through to that point. So I'll carry on monitoring with the scope on C205 and see if we get any signal change if we change the ranges, but it looks like it's possibly something at the very front end, and it's quite likely if someone's put too many volts through it, it might have blown up a relay or something like that. So let's just see if we can find this signal. So get the scope on the trace. We are on AC. I'm going to change ranges now. So let's see where the range control is. Move this back a bit so I can see what's happening. I need to try and make up something so I can actually stand this on without it falling over all the time. Display. So it must be this one, mustn't it? No. still trying to get the hang of this thing. That's AC current, on that AC volts. Manual range, that's it. So let's have a look. Watching the scope again for any change in waveform. Something's not right there, I don't think. I don't think that is right. It does say that top of that waveform should be connected to right, what we could try, just to see what it does. I suppose we could feed a small signal in there, but maybe with the scope probe from these, from the audio and the signal generator, just so we get any reading on the meter itself. So the meter is actually reading sort of like more or less nothing at the moment. Let's see that. The displays aren't the easiest ones to see. Let's bring this down a bit so you can see. Where are we? And of course the exposure, the camera always tries to expose the brightest area, which is always very useful. Okay. Right, should have a bit of a signal on here. I'm just going to poke around this point here. I'm using the times 10, so I'm not going to put any serious current through the thing. Just so we can get any change in signal. Nothing there. Nothing there. So normal straight connection. No, it doesn't seem to be doing anything. Oh, I've got 2 volts AC there. Okay. Right. That's interesting. That's obviously well down on what it is, but of course we're not going through half of the switching. So the next thing I think to do is to actually ascertain that this relay is actually switching correctly, work out what this relay does, and go from there. Trying to get my head around how this circuit works. There is some signal getting through, and it's very weak. Now, maybe some of my viewers can help here. Signal's coming through here. This is a various switching for, it looks like attenuation. The signal comes through these lines here and selected by these FETs. These FETs all switch. That all seems to work okay, apart from this one seems to be doing a bit something odd. It seems to be permanently, that gate's permanently low, so that FET is permanently turned off, I think that means. So, because these are J FETs, so if you apply signals to the FET, the transistor turns off, basically. That J FET by design is on all the time. Signal comes through here, comes up to this transistor here, this long-tail pair, I think they call them. Sort of like a mirror amplifier, current amplifier, or current mirror, I think. I don't know exactly how this works, but it looks like this op amp here tries to balance these 2 points here to keep this level the same. This chip here is the thing I'm a little bit confused about, and I think this is a sort of like a negative feedback circuit. So our signal gets to this point here, comes into this chip, and is fed back into this op amp, and is fed back into the circuit. Now, if that's the case, if this thing isn't working correctly or it's not switching, we're not getting any negative feedback, and therefore the level's not shifting. Now, that's the sort of problem I'm getting at the moment. So I'm going to try and have a look at these lines here and see if anything's changing on these data lines. I assume they are. I can actually get hold of one of these chips. There are a couple on eBay, but at the moment I'm still trying to get my head around how this circuit works. So the next step will be to have a look at these, have a look at this chip, see if I can work out if it's actually doing anything. I'd expect a level change on the signal on pin 16, so let's have a look at that next. Right, I think I've worked out what's actually wrong with this. Been through all the circuit, everything seems to work how it should. There's a couple of things here I don't entirely understand how they work. This chip here seems to be some sort of like bandwidth limiting chip. It's connected to the screen of these leads, actually like a sort of like a guard, excuse me, around the signal, acting like a sort of increase in the capacitance. I'm not entirely sure what it's doing. That's not the problem though. The signal's getting through okay. The signal's coming out here on this test point here okay. And if I go to frequency and press the frequency range, which is obviously all done with AC conversion, I get a nice clean signal here, and that's the frequency switch that activates that transistor that turns this op amp on. And you get a clean frequency out of here, and it doesn't matter what level signal you put in, even a really low signal, the frequency is accurate and comes out here. This looks like all parts of like a negative feedback circuit, and that's all I think tied in with sort of this part here, which is actually the problem. Signal comes in here and is fed into this chip here, which is an AC to DC converter. Basically, it takes the AC RMS signal, converts it into a DC level, and that level should appear on this output pin here. It doesn't. All we get is like a weak AC signal. So I tried to track this chip down, this U305, and it's unobtainium. And of course that's probably why this meter has been sold, because the chip is irreplaceable. And for those who are interested and who might have any idea where I could get a chip for it, it is this, so let's see here, just focus in here, analog switch. No, it's not, ignore that, it's the RMS to DC 14 bipolar, it says, and it's the device number is AD41790. Well, that's what it says in the actual in the manual, in the service manual. But when I actually checked and took a photograph of the actual chip itself, it comes up as a what is it? As an AD1826, and it says /1301. So it looks like this meter will work perfectly fine on DC and AC frequency, but it won't work correctly on AC volts. So at this point now, I'm going to put this meter back together, and I think what I'll do is I'll just make this make this part one of the video, and then we'll have a go at doing some sort of calibration on the DC side and get the meter accurate, and then just keep a feeler out for that new chip.